Hi friends, my name is Ogodino Uche Jude. Welcome to this physics online classroom. Our topic for discussion today in physics is called semiconductors. So without much ado, let's see our lesson objective for this particular lesson. So by the end of the lesson, the student should be able to differentiate between conductors and semiconductors, explain the mode of operation of semiconductors, explain movement of free electrons and creation of holes, explain doping and how it is used to create N-type and P-type semiconductors. Now, mode of conduction of semiconductors. Conductors and semiconductors have different mode of conduction. Conductors conduct electricity using free electrons. So, what is a conductor? We are taught in our junior classes that conductors are those materials that allow the flow of what? Electricity, or allow the flow of some external agents such as electricity or heat. So, in this particular context, we are talking about what? Electricity. So, conductors, like metals, conduct electricity through what we call free electrons. And why are they called free electrons? They are called free electrons because the electrons are readily available for what? For the conduction of electricity. And they are free electrons because they are not firmly bounded to the atom. So the difference between a conductor now and an insulator, if we must digress a little, is that conductors, the electrons are free. They are not bounded to the what? To the atom. But insulators, the atoms are bounded to the atom. So they are not readily available for what? Conduction of electricity. So that's the big difference between conductors and what? Insulators. And mind you, insulators are those materials or substances that cannot conduct electricity. Now, another kind of material or another kind of substance that can conduct electricity are known as the aqueous ionic compound. Aqueous ionic compound are just chemicals that are used for what? Production of electricity. Like, for example, in your electrolysis, you were taught about some chemicals that can actually dissociate into positive and negative ion when an external voltage from a source of EMF, such as a battery, is applied across the what? The terminal, that's the electrode, the positive rod, negative rod, or plates, as the case may be, whatever they are using as the what? Electrode, and so on and so forth. Now, the positive charge carriers or the charge carriers in an aqueous ionic compound are the positive ions and the negative ions. Now, semiconductors. Semiconductors use two types of charge carriers: negatively charged free electrons and positively charged holes to conduct electricity. So that is what semiconductor actually use for their conduction of electricity. So to understand better, let's move forward. Now, creation of free electrons and hole semiconductor, typically in atom of germanium or silicon. Now, these are basically the most frequently used types of semiconductor. They belong to what? The group 4 elements. So if you look at your periodic table, you see germanium and silicon in what? Group 4, because their electrons at the atomos share, that's their valence electrons are 4. Or rather, simply put, they have 4 valence electrons from their crystal structure. So at very low temperature, almost all the valence electrons are firmly bounded to the nuclei. So at low temperature, they behave as if they don't have free electrons at that particular temperature. So they are firmly bounded to their what? To the atom of their crystal lattice. They are bounded to the atoms of their what? Their crystal. So the semiconductors has practically no free electrons to conduct electricity at this state. That is very low temperature. But at room temperature, however, room temperature can begin from 20-something degree to 30-something degree. So at room temperature, which is higher than very low temperature, thermal energy may be large enough for the valence electron to be liberated from the crystal structure. So thermal energy is what we call heat energy. Another word for thermal means heat energy. So this heat energy is sufficient enough to liberate an electron from an atom. So liberation is just a big word for what? Moving or pushing away or jumping away, whatever you want to call it. Just view it as if an electron is flying away from what? The atom. So the liberated valence electron becomes free electrons for the conduction of electricity. At this juncture, let's look at the diagram to understand better. So look at this diagram. Now look at a combination of silicon. Si represents the silicon, and this silicon, now look at how they are bonded together. The electrons at the outermost shell of the atom are bonded to other atoms. They have 4 valence electrons. So this is their combination. They are bonded together. Now, in this particular bonding, look at this diagram. If you look at this diagram, you see the arrow showing how an electron jumps or moves away or liberated. Let's use the word being used now, liberated. But I told you that liberated means what? Jumping away, moving away from that particular spot. And when the electron moves away from that particular spot, there will be holes created. So this hole is now our positive charge carrier. Now, the electrons are our negative charge carrier. So look at the diagram again. A hole is formed in the crystal structure. Atom of silicon in the crystal structure. So it is temperature, increase in temperature that causes this effect. So without temperature, they behave more like what? An insulator. But if the temperature is sufficiently increased, let's say from room temperature or further increased away from room temperature, then this particular phenomenon is what? Achieved. So now, movement of free electron and holes in semiconductors. Now, this is exactly what happens internally in the crystal structure of what? Semiconductors. So in a semiconductor now, look at this particular atom, A. It has 4 valence electrons. Look at the other one, B. It has 4 valence electrons. Now there is a movement, there is a hole created in A. Hole in atom A. That hole is as a result of what? The liberation of electron from that particular spot. So there is need for that hole to be what? Filled. So the atom in B, the electron in atom B moves from that particular spot to field, and the circle continues. Look at the next diagram with the dotted lines, or the next part of the diagram with dotted lines. Okay. Now this diagram, now look at it. It's trying to tell us that when there is now hole created in this particular point as a result of the movement of this electron to fill up this first hole, then the next atom will also do the same or will follow suit. And when that happens, the cycle continues and there will be conduction of electricity. So we now have equal numbers of holes and equal numbers of what? Free electrons. So your hole represents your positive charge carrier. Free electron represents your negative charge carriers. Okay, that is an internal structure of what happens. But what of a situation where an external source of voltage is applied? External source of voltage is applied. That initial case, in this particular case, an external source of voltage may not be needed for this to happen. It's just the temperature that is needed for this particular movement, creation of holes, and filling of the holes to occur. But this particular diagram now is explaining what happens if that semiconductor is now connected to an external source of EMF. And that external source of EMF can be your battery, or can also be other sources of electricity, such as your what? Alternating current. If you are using your battery, that is what? Direct current. So the electrons in this diagram represent, these electrons represent red circle. The green circle represents holes. So what is actually happening now? External voltage, positive, negative. So our electrons are migrating towards what? Positive potential, while the holes are migrating towards the negative potential. Meaning electrons that are negative are moving towards or going towards the positive part of the battery, and the holes are moving towards the negative part of the battery. So effect of temperature on electrical conductivity of semiconductors and conductors. So what's the effect? Increase in temperature, increase electrical conductivity. Yes, this makes sense because as the temperature is increased, that means there will be faster liberation of what? Electrons and creation of holes. more temperature, more liberation, increase in liberation, and there will be more holes also created. So electrical conductivity is increased with increase in temperature. That is for semiconductors. But for conductors, if you increase the temperature, there will be agitation of the metal. If you're talking of metals now, the molecules which the metals contain will be vibrating together. And as they're vibrating together like that, their electrons now will be impeded. The electrons will be slowed down, and therefore there will be high resistance. And if there is high resistance, it therefore means that there will be what? Slow movement of free electron, leading to low production of electricity, or leading to lower conductivity. That's the right word, low conductivity. So like I said, low conductivity, not generation of electricity, but low conductivity. So we can conclude that increase in temperature decrease the resistance of semiconductor. Yes, increase in temperature will reduce the what? Resistance of semiconductor. Semiconductors cannot resist it, so there will be increase in movement or liberation of electron, whereas the opposite is the case for that of what? Conductors. So we conclude that increase in temperature decreases the resistance of semiconductor and increase those of what? Conductors. Conductor resistance to free electrons is increased, but the semiconductor resistance is not increased, because if you increase the temperature, there will be free flow of what? Free electrons. So types of semiconductor. A pure semiconductor is called intrinsic semiconductor. Doping is the process of adding a small amount of impurities to intrinsic semiconductor. So what is a pure semiconductor? A pure semiconductor is a conductor that has not been mixed with any element from any group, such as group 5 and group 3. So when we use or apply small impurities from other groups, such as arsenic and boron, to a pure conductor, then that process is known as what? Doping. Let's go over it again. A pure semiconductor, no doping process, no impurities added. It's just the silicon or germanium that is what? At its normal state. But when you add an impurity such as arsenic in group 5 or boron in group 3, then there will be different type of what? Semiconductors created. So if you do that now, adding of that impurity is known as doping. So for your examination question, you come across doping a lot. If they ask you what doping means, you simply tell them that doping is the process of adding a small amount of impurity to intrinsic semiconductor. Intrinsic when it is pure, but when you add impurities, then it is no longer pure, but becomes extrinsic. It becomes extrinsic semiconductor. So there are two types of semiconductors, the N-type and the P-type. So extrinsic semiconductor N-type. The N-type extrinsic semiconductor is produced by introducing a small amount of suitable impurity, an element in group 5 such as arsenic, to an intrinsic semiconductor. So now this is a diagram of extrinsic N-type semiconductor. Now, if you look at this bonding, let's look at this bonding critically. This is the first silicon atom. Silicon atom is now bonded to arsenic. Arsenic is what? From group 5. Now look at the combination. During the bonding, 4 is readily available for bonding because this arsenic has 5 valence electrons. So if you look at the kick diagram very well, this is valence electron for silicon and this is valence electron for arsenic. So in the bonding, there is always one free electron not used in what? In the bonding, from the valence electron of the arsenic atom. From the valence electron of the arsenic what? Atom. So at this particular time now, other atoms combine together and performing this kind of bonding. There is now free electrons or more electrons than holes. In this particular type, there is more electrons than holes, and that is why it is called N-type semiconductors. So they are called acceptors also. They are called donors also because they readily have electrons to donate to what? To another atom that has holes in them. So these are called donors, and they are also called N-type semiconductors. So extrinsic semiconductor, P-type. The P-type extrinsic semiconductor is produced by introducing a small amount of suitable impurity and elements in group 3 such as boron to an intrinsic semiconductor. So this intrinsic semiconductor group 2, let's go to the diagram. Look at the diagram. The difference between this first diagram is this boron is a group 3 element. So they have 3 valence electrons readily available for what? For bonding. So if you look at this diagram, there is always a hole created because it is not complete. It is not up to 4. So because there is more holes created than what? Electrons, free electrons. There's more holes created than free electrons. This is called a p-type semiconductors. So this type of semiconductor, extrinsic semiconductors are p-type. They are also known as what? Acceptor, because they accept electron. Whereas the first case, they are called donors because they readily donate free electrons. So this is the end of slide. So with this, I hope you understand what semiconductor means. Let's go over it again. A summary of what we have learned today. We learned about the mode of conduction of what? Semiconductor, the difference between semiconductor. I also involved or digressed a bit, adding insulators. Insulators to the conductors and semiconductors. We also discussed the type of semiconductors. We have N-type and the P-type. We said the N-type are called what? Donors. While the P-type, they are called what? Acceptors. And we went further to talk about doping and every other thing involved in this study. So with this, I hope you'll be able to really understand what semiconductor actually means. So in our next revision class, we talk about the NPN semiconductors and we talk about the PNP semiconductors to conclude the semiconductor lectures. So until we meet again in our next class, this is your favorite teacher, Mr. Jude. So have a nice holiday. Take care.